Hey guys, welcome back. So we're gonna pick up where we left off. So we introduced the reals. We talked about potential between the two. We talked about the oxidation half reaction. Leo's on the left, so right cat. So cat. There's a lot of things that go with it, and be expanding on that, adding to that conversation that we can use to quantify and to further categorize the same experience. So the homework from the take cells. That's how do we cells for this, and then homework that goes with the standard reduction potentials. Okay, so let's go and check. And let's see. The first thing we are going to be talking about is so what do we mean by redox? What exactly does redox mean? Well, D is for reduction, and ox is for the oxidation. And we listed as one more because we need oxidation atoms so that they can gain somewhere else. Those gain so Leo is losing electrons, oxidize, and gain electrons, reduce. So oxidation is lost. Balance the following equation in acidic solution. Okay, so acidic solution. Thing that we're trying to balance here is H3P2 C2 2 H3P4 plus Cr. Okay, two half reactions. H3P2 H3P4 and Cr2 to give me C. Go opposite. So those are the half reactions. The next is balancing for P and Cr. So I have 1P on the reactant side over here, 1P on the product side over here. Two CRs on the reactant side here, and only one there. Two. So that's my P and Cr. So this should technically be two Cr plus, and take that out because I have two different lines because that's me. So there we go. All right, we got that. Now we're going to do oxygen. And I'm just going to list it because I hope H2O. So I have two oxygens in my reactant side over here. I have 4 over here. So I'm going to take H3PO2 plus 2H2O, give me H3PO. And I have Cr2O7 2 minus. I have 7 oxygens there. Cr2O7 2 minus. There's 2Cr3 plus 7H2O. Okay, awesome. Well, now I messed up the protons, so we're going to do H again. I have 3 hydrogens here and 3 there. Oh, no, not 3. 3 and then 7 total. And then 3 on this side. So I need to add 4 over here. H3PO2 plus 2H2O with me. H3PO4. And so I need plus 4H plus. And I have 14 H's that I added there. So 14H plus Cr2O7 2 minus 2Cr3 plus 7H2O. Okay, awesome. I already wrote that, so I'm going to erase it. I don't need that. 3 plus. Okay. So that's what we have there. Now we've gotten through everything mass balance wise. We need to look at our charge. Now, net charge in this reaction. On my reactant side, I've got no charge. On my product side, I have a 4 plus. So I need to add 4 electrons. H3PO, that's not a 4, that's a 2. Plus 2H2O plus H3PO4 plus 4H plus 4E minus. When I look at my second reaction, the second half reaction, I have 14 minus 2, that gives me a plus 12. Okay, and on the other side, I have a plus 6. So I need to add 6 electrons plus those 14H plus Cr2O7 2 minus to give me 2 Cr3 plus 7H2O. 6 electrons here, 4 electrons there. If I multiply this equation by 2 and this one by 3, then I will get lowest common denominator 12. So 3H3PO2 plus 6H2O, 3H3PO4 plus 12H plus 12 minus. If we do this one, we have 12E minus plus 28H plus 2Cr2O7 2 minus, give me 2Cr3 plus 14H2O. So the electrons cancel. That's good. We want them to. I have no commonality for the PO4s. I have 6 H2Os over here, right there, and 14 over here. So I can cancel this 6. That leaves me with 8 there, because that's the math on that. I have 12H plus right here. I have 28 on the other side, so I can cancel the 12. And that's going to leave me with 16 H plus. And so if I write all of that happy stuff down, because I canceled things, 3H3PO2 plus 16H plus 2Cr2O7 2 minus. It's going to give me 3H3PO4 plus 2Cr3 plus 8H2O. CrHO P, and then my charge. Okay, so I have 3 times 3 is 9. 9 and 16 is 25 hydrogens. I have 4 chromium. I have 14 oxygen from the chromium. 14 and 6 is 20 oxygen total. And then I have 1 P. And my net charge, 16 plus minus the 4, is going to give me 12 plus. When I look at the other side, it's a little more complicated because I need to move things. So I see a problem right here. I see that I have 2 chromiums on my product side, and that's a problem, which it is because I didn't multiply the 2 times the 2, so this should be a 4. So when I did this multiplication here, this should have ended up being a 4 right there. Hence why I write all of this stuff over again, because then it's easier for me to find that mistake. So I have 4. 9 plus 16 is 25 hydrogens. 12, 20 oxygens. And my net charge is 12 plus. And how many P's do I have? Well, let me scroll a little bit. So I have 1 P, which is what I thought, but I have 1 P. Yes, everything balances. Go! Awesome. I love it when that happens. So I did make a mistake, but because of the way I write things down, it was one step back to see that I had made a mistake. I hadn't carried that multiplication 2 all the way through that half reaction. And that is a common problem. People forget to carry it when they're writing stuff down again, and it becomes an issue. Okay, let's talk about balance the following equation in basic solution. HO2 minus plus CrOH 3 CrO4 2 minus plus OH minus. And this is basic. Okay, fine. So that's what I'm looking at. I need to have 2 half reactions for this. So my CrOH 3 goes to CrO4 2 minus. And I have an HO2 minus goes to OH minus. Okay, awesome, that's fun. All right, so that's my half reactions. Let's talk about chromium, because that's the only thing I have other than oxygen and hydrogen. I have 1 chromium on each side, so I'm not going to rewrite that. Let me talk about the oxygen. I have 3 oxygens right here. I have 4 there. So I'm going to CrOH 3 plus an H2O. So CrO4 2 minus. And then on this one, I have 2 oxygens here and only 1 there. So it's going to be an HO2 minus going to OH minus plus an H2O. Cool. Now we're going to balance for the proton, or H with protons. So I added 2 here, and I have 2 there, and 3 there, that's 5. So CrOH 3 plus H2O, CrO4 2 minus plus 5H plus. Here I have 1H, 1H, 3 H's. So 2H plus HO2 minus OH minus plus H2O. Okay, let's look at our charge. I have no net charge here in my reactants, but I do have net charge over here. So I have a 2 minus plus the 5. That leaves me with a big plus 3 charge. So that means I'm going to have 3 electrons there. So CrOH 3 plus H2O, CrO4 2 minus plus 5H plus 3. Then I'm going to have, so I have, those are equal. So I have 2 H plus that are not equal. I need to add 2 electrons. 2 E minus plus 2 H plus HO2 minus. So OH minus plus H2. Okay, awesome. Not the same number of electrons. So I'm going to multiply this one by 3. This one by 2. It's going to give me 2 CrOH 3 plus 2H2O E2CrO4 2 minus plus 10H plus 6E minus. We have 6E minus plus 6H plus 3HO2 minus, leaving 3OH minus plus 3H2O. 6 electrons, 6 electrons. Get rid of the 3, cancel that. And I have 6 protons here and 4 there. Okay, let's add on stuff. So 2CrOH3 plus 3OH2 minus. And give me 2CrO4 2 minus plus 3OH minus plus H2O. Because remember, we canceled the 2, so it's only the 1 H2 that's left. Okay, awesome. Now, do I have any excess protons? Where are the protons? Because I should have more protons. Yeah, I still have 4. I forgot to bring these 4 down. So I have 4 protons. 4 protons are not acceptable in the basic solution, so I take 4OH minus plus 2CrOH3 plus 3OH2 minus to give me 2CrO4 2 minus plus 3H minus plus H2O plus 4H plus 4OH minus, which becomes water. So that leaves with 5H2O over here. Yep, and that's 5. So I'm going to combine all of these H2Os plus 5H2O. And that's my balanced equation in base. Well, that was fun. Go review. So we're going to stop here, get this part uploaded, and then we'll move on to our next part of this discussion. All right. Talk soon.